Ladies and gentlemen, a very good morning. Firstly, I would like to apologize for the delay in this webinar due to some technical problems. Welcome to our Humanizing Innovation at MMU webinar series entitled Product Design for Sustainable Manufacturing and Safety. This webinar is organized by the Industrial Collaboration and Engagement Center, ICEC, and the Center for Advanced Mechanical and Green Technology, CMGT, Faculty of Engineering and Technology. Thank you for joining us today. Chen, the moderator for today's event, currently a senior lecturer with the Faculty of Engineering and Technology, Multimedia University. Nice meeting you here. Let us begin. What is sustainability? Former Director General of World Health Organization, Gro Harlem Brundtland, said before, sustainability are developments that meet the needs of the present without compromising the needs of the future generation. Putting this in the context of manufacturing environment, on product level, sustainable manufacturing is related basically to the approaches to reduce, to redesign, to recover, remanufacture, and to recycle. On the process side, sustainable manufacturing is basically meant to reinforce energy consumption reduction, to eliminate toxic produce, to reduce waste, to prolong product durability, to recycle, and so on. So product design and process developments are focuses to achieve the environmental, economic, and social aspects of sustainability. For safety, a crucial aspect of product design is also an aspect of sustainability from the social perspective. Today, we have two highly accomplished mechanical engineers with us. We'll share about how they overcome sustainable challenges in the manufacturing industry. That brings us to the topic for today, which is product design for sustainable manufacturing and safety. Our first speaker today is Mr. Roslin Tamsil from Yinsen Holdings Berhad. Today, we'll learn some insights and experience of his in the design and development process for the sustainable manufacturing from this Mr. Roslin Tamsil from Yinsen Holdings Berhad. So welcome to MMU Humanizing webinar series, Mr. Roslin. From MMU, we have IR Dr. Kok Chi Kwang. Dr. Kok will share his experience on the design and performance of a walkie-talkie manufactured in compliance with the specific safety requirement by ATEX. Welcome to the webinar series, Dr. Kok. Let me introduce our first speaker for today's webinar, Mr. Roslin. Let us look at his biography briefly here. Mr. Roslin Tamsil is currently the Senior Vice President Electromobility at Yinsen Holdings Berhad. He received his Bachelor in Mechanical Engineering from Ravensburg-Weingarten University of Applied Sciences, Germany, and has been in the design and development of high-quality sound system and speakers for premium cars like McLaren. Wow. In fact, I came across in the news that he holds a patent in the novel design of speakers enclosure. So we are looking forward about more of this in the later section. If you have any questions for Mr. Roslin, please post them in the chat box. Mr. Roslin will answer them in the Q&A session later. Let us welcome Mr. Roslin. Over to you, Mr. Roslin.
Thank you, Dr. Chen. Hello, everyone. Okay, first and foremost, I would like to express my gratitude to MMU, Dr. Evina, Dr. Koo, my fellow speaker, Dr. Kok and Dr. Cheng, and all others who have contributed to this event. So my name is Roslin Tamsil. I am currently residing in Cyberjaya. So today I will be talking about the product design for sustainable manufacturing and safety. So in this topic, I will be sharing my previous experience with all of you and we will discuss all together about the product safety and product design all the way long. Okay, I hope this will be a very valuable session for all of us. Okay, so are we putting the slides? All right. Okay, the next slide, please. Okay, thank you. So today I'm going to start with a little of introduction of myself, a little bit of my background, some of the exciting projects that I have been involved during my tenure from my previous company. So we will touch a bit about the product design and development, the example of design failure and its consequences, and I will explain a little bit about the product development process. Then we will go to sustainable manufacturing, the definition, and some negative impact of it from the global point of view. And more importantly, is what is our role in this? And then I will be able to answer some of good questions from all of you. Okay, next slide, please. Okay, let's start with the introduction. Next slide, please. Yeah. So I was born in 1984 in Kuala Lumpur. Now I am a father of two. In 2015, I received a scholarship from Malaysian government to further my study to overseas. So since I like engineering so much and particularly cars, so Germany was my first choice. So I was lucky to get to go and learn from the world's best engineering country, right? And after a few years of struggling with the German languages and the very straightforward bureaucratic systems in Germany, in 2010, I graduated from the University of Applied Science Ravensburg Weingarten, where I studied automotive and mechatronic system. At that time in Germany, particularly at the university, we are still using the old system, the old education system, which is called a diploma. So I am a so-called diploma engineer and might be one of the last diploma engineer uh, alive. So, so after graduated, I came back to our beloved land and with a vision to serve for the land and for the industry. So I was lucky to get my first job with a well-known German company, Continental in Penang. There I was responsible as mechanical design engineer within the R&D department. Here I learned my first experience dealing with product design and development, where I learned tremendous knowledge about product safety as well. After that, I got a better offer to work with Motorola Solutions. So here I learned about public customer safety, as Motorola is known for safety products like walkie-talkies and radios. Um, uh, these are used in public safety like ambulance, fire brigade, police, and in the army. So after that, I got bored a little bit on consumer product and would like to be in the automotive sector again. And I got an offer to join Robert Bosch in Penang. Not so long while I was working with Bosch, I got a call from Germany saying that they are looking for somebody with like me with the product design and automotive background. So I undergone few telephone interviews and they invited me to Germany for a personal interview. And then I say during the interview, and I say yes, and then I got the job offer right away. So then I came back home with a big smile in the face, and then we were busy preparing ourselves to move to Germany. So I spent more than 5 years working in Germany, where I learned priceless experience while working with the company Harman International Industry in Munich. There I learned how the German culture of work, how they solve issues and problems in engineering manner, and more importantly how they take the responsibility of their own invention and product to ensure the sustainable manufacturing. So back there I had a chance to work with some of the biggest car manufacturer like Volvo, BMW, McLaren, Mercedes, Ferrari, and many more. Also in 2018, 2019, I managed to file a few patents under my own invention while I was working with McLaren and also Bowers and Wilkins. in the mid of 2019, I decided to give up my dream job, my so-called dream job, because I can see a huge potential of driving automotive business in Malaysia. So I had the idea of building electric bus for Malaysia. So I gather my team, we pitched the idea to few investors, and finally we secured a deal, and I formed a company in Cyberjaya. So the company is called MQ Phoenix. And as everyone know, we are unlucky within 2020, where the COVID hit us, and it came, and our business was going south. So we were in the midst of we were in the midst of developing our prototype bus, but we finished our first prototype. But financial is not with us, so we move on, and I move on to join another transportation company called Linchen Berhad. So since 2021, this year I work with Yinsen Berhad, and I found my second chance of bringing the automotive industry in Malaysia to the next level. So here you can see some pictures of my invention. On the left is the tweeter on top, and then the second one is the door speaker package in carbon fiber enclosure. And then the next one, you can see the cockpit of a McLaren Senna P15, and then the McLaren Senna itself in the orange color. Okay, next slide. All right. Um, in 2010, I started my career. I had a chance to develop exciting product like instrument cluster, or we call speedometer. So I work with our national car manufacturer like Proton and Produa to produce meter cluster for some of their models like Proton Saga, BLM facelift, and also Produa Viva facelift. Apart from that, I was also responsible to develop a head-up display, or we call it a HUD, for a Taiwanese car manufacturer called Yukon. So since Yukon has been acquired by GM, the head-up display was placed in some of the GMC vehicles. So I hope you heard about the GMC. So they're making big trucks and also four-wheel drive trucks. So as all you can see here, and the left picture is the head-up display itself, the module which is placed under the dashboard of the car. So at the top side, you can see the reflective mirror made of polycarbonate, and at the bottom side is the kinematic module. So when the car starts, the mirror will move upwards and reflect the information like vehicle speed and other important warning indicators. Now I want to ask the audience, what is the safety feature behind this product? So why do we need a second display when we already have the speedometer and other indication in the car, right? So will this make the driver even busier to see all the information in the car? So actually this head-up display will help the driver to be even more focused on the driving and staying alert on the road. So the driver will not need to move his eyes from the road and the traffic just to see the speed of the car at that time. So this is the speed indicator on the head-up display, so he can be more focused. So it is like having the information that you need within your safety view on the road. What are other safety features that I, as a designer who developed this product, need to think about? Right. So for example, the mirror itself. So you can imagine during the road crash, a piece of extruding glass right before your eyes. So that would be fatal, and definitely a wrong thing to have in the first place in your car, right? But since customer really want to have this head-up display mirror inside the car, then what should I do? I cannot simply say to the customer, no, it is not possible to place the mirror in that position. We cannot simply say to the customer that we will not do this project because it is unsafe. So those are the problems that I need to solve. And how do I ensure the mirror will not break? So I need to think of a material that is suitable to be used for this mirror, right? So I need to ensure that the material is a see-through material. So as a responsible engineer and as somebody need to think about the safety, we need to have more knowledge about material science. So we did our research and we brainstorm with our team, and then we have a conclusion to use a plastic material like polycarbonate for this purpose. Then there are a few issues that we had with this material. For example, it is a non 100% see-through. And then what else? The melting point is very low. So the polycarbonate might melt in the car under the hot sun, and then the material itself would be yellowish over the time. But those are the technical issues that we need to solve with other engineering department as well and in our team in order to ensure that this product is reliable and safe. So these are the things that we as engineer, developer, and manufacturer need to do to enhance the safety of the product design. So in the picture, you can see the car itself and then the protruding mirror in the car, which is so-called a head-up display. Okay, next slide, please. Another interesting project that I had developed is um, battery packs for walkie-talkie while I was working with Motorola. So here I've learned my first experience with lithium ion and other mineral batteries. So here I learned about sustainable manufacturing, whereby a lot of mineral is consumed to produce such product, right? So here also I learned about the public safety, as we know that walkie-talkie is just like a mobile phone. So the consumer use and carry the walkie-talkie on their body, and here the safety of the battery packaging itself is very important. So we have heard about the mobile phone exploded in the airplane until some airport banned a certain model, right? From a certain company a few years back. So this is the importance of the safety in the product. So we need to ensure that the walkie-talkie is safe everywhere. Some of the walkie-talkie is used in a very hazardous area with a high rate of flammability. For example, in the oil rigs for the oil and gas company, a small spark from somewhere can be a total nightmare for the whole plantation, right? So we engineers, we need to ensure that this product is safe. And how we are going to do that? We need to ensure the packaging design is safe by using the correct material, the correct assembly tolerances, for example, and we need to do extensive testing for the product, for example, like the drop test, flammability test, etc., etc. And after a few years of exciting work with Motorola, I got another offer for a job in the robot Bosch, and I just grabbed the chance. And there I had a few experience working with some Japanese manufacturer like Suzuki and Nissan, so to develop the fascia of their navigation unit and information system. Okay, next slide, please. So in 2014, I started my career journey with Germany, in Germany with the company Harman. So I got a chance to develop premium sound speaker under the brand like uh, Bose & Wilkins, Harman Kardon, JBL, Mark and Levinson, ADKG, and other brands. So these speakers I used in premium cars like BMW, Volvo, McLaren, Audi, and other well known as well. So some of you might have already been thinking, what are the importance of speaker for safety, right? So speaker cannot do anything to save life, right? No, actually it is not correct. So speaker in the car is the most important feature used for safety. So they make good sounds and quality audio in the car, but not only that, the technology is evolving nowadays. A car can give a notification to the driver when something dangerous is about to happen, like crash. So predictive crash notification, lane assist notification, understeering, oversteering, low fuel warning, you name it. Now a car can tell you that you are already sleepy and you need a coffee break, right? So that is the importance of audio system in the car as well. So with this latest technology that we have right now, the for example, the electric car, we know that electric car does not produce a loud engine sound and they don't have an exhaust sound like the internal combustion engine. So let's take example if I am a pedestrian near the road, right? When we walk on the sideways and a car is approaching, so I would have known that a car or a bike is passing through. So I will be alert and cautious, right? So what if an electric car is passing through near me, and I would not have I would not have noticed it earlier until it's too late. So I might change my walking direction, or I might cross the road knowing that there is no car nearby. That would be dangerous to me and the others too. So here are the importance of having a sound system in the car, where right now there is a new regulation saying that an electric car must produce a sound when drive below than 30 kilometer per hour, for example. So it is for pedestrian safety. So what is being done to ensure this? The automaker is putting the speaker outside of the car, and particularly in front of the car and at the back. So this speaker will produce a warning signal while reversing and also cruising at walking speed. So apart from that, during this time, the company is developing a noise cancelling technology, so-called Helosonic, so which will cancel the road and the traffic noise entering in the car. So it's only allowing certain frequency like ambulance siren, the car horn, to be transmitted into the car. So there are other technologies being developed like the advanced driver assistant ADAS, we call it, um, that will help the driver to stay alert and finally avoid unintended driving maneuver. So these are the example that we engineers, developers, and manufacturer need to think of how to ensure the safety in our design and product development. Okay, next slide, please. Okay, so as mentioned, I was leaving my dream job in Germany. Um, I went back to Malaysia to pursue a bigger hope. So in 2019, I formed a company to develop electric bus. Here I was leading the development and the operation. So we had a team of engineering and manufacturing who are responsible for the bus development and also for the safety. So the bus is featured with a ADAS and also autonomous braking system to ensure the safety level. So when we are taking when we are talking about bus and other public transportation system, right? Safety is always number one. So as we heard a few couple of days back, that one of our public transportation operator had one of the biggest head-to-head accident that lead to severe injuries to the passenger, right? So what is the cause of this accident? So how can a proven system provided by a well-known company like Bombardier from Germany can still have this kind of error? And who is to blame, right? So that is for us to answer ourselves, right? Because machines are made by men, and there is no man who is perfect. And yet, our responsibility is to make the system perfect. So every single person who are responsible for the product, be it engineers, the component suppliers, the operators, they are, or we are responsible for each public safety measures and any design faulty to be fully proven and tested prior to the operation. Okay, so next slide, please. Apart from the electric bus development, we also providing some engineering services and consultation like design, styling by using software like CATIA alias. So simulations by using ANSYS or Altair, and some physical testing with collaboration with some local certification bodies. And since I have a few experience with carbon fiber and also composite manufacturing, so we also provided some product development and manufacturing composite parts like car performance body kits. Okay, so these are the activities that we have done. Next slide, please. All right, so since March this year, I joined an oil and gas transportation company, Yinsen Holding Berhad, who like to pursue the idea of sustainable manufacturing. So the company is also committed to be carbon neutral by 2030 and carbon zero by 2050. So in the pursuance of this goal, my responsibility is to ensure that we embark the green technologies provide solution by providing green and electromobility and also the ecosystem. So some of the projects that we are working on right now are namely electric bus, electric charging stations, autonomous vehicle technology, and many more. So we are going to electrify Malaysia. Hence, we will improve our air pollution, especially in the cities, whereby most of the conventional internal combustion engine that produce a lot of greenhouse effect will be replaced by electric vehicle. This is a truly sustainable ecosystem that we are providing in the next few years. Next slide, please. Okay, so just now I talked a bit about product design and product development. Um, let's see what are the example of having a design failure that we could encounter in our daily life. Next slide, please. So as you can see this picture, right? So what are the designer and the manufacturer of the toilet door thinking about? So why do we want to have a nice, cute coffee cup that will hurt our own eyes, right? So it may be funny, but it might not affect our safety at a certain level. Yeah, design failure is something that exists everywhere. Next slide. And what if the design failure will cost us our life, our beloved ones? So will we be laughing at a burning Toyota or maybe a falling Max highway? So this is the importance of safety, right? And the safety that we could prevent if we make sure our product is mature and following the requirement standard. So, but how are we going to make sure the product is safe? So that is the role of the engineer like you and me to make sure that this won't happen. So we could have predicted this failure at the very beginning, even before it is manufactured. So there are many tools, there are international standards and regulation specification that we need to ensure the product is complying with. So for example, there is a IATF 16949 for the functional safety of automotive. So we have the ISO 26262 uh, for the safety of lithium-ion battery in the public vehicle. We have ISO 10377 and 10393 for the public safety as well. So those are the regulation and standard that is set by the international agencies to ensure the safety. Okay, next slide, please. All right, so next I'm going to talk about the product development process. So this is very important to understand the process where the safety standard will be implemented in any products. So I'm taking example of a common industry product development process here. So it will start with brainstorming. So here all the input gathered by other parties, be it from quality department, engineering, sales, marketing, management, operation, and legal teams will sit together and make the product requirement. The product requirement will then be analyzed by the expert to ensure the compliance of the product according to the uh, quality and safety standards. And then it will lead to the conceptual design done by computer program and then model in a 3D aspect to see the real shape of the design. And here is the very important to have the product reliability according to its design and tolerances. So after virtual validation process will take place, where the design model will be simulated according to the test constraints. Simulation will predict the product stability and the characteristic under stress condition. So the next step will be the prototyping, where the simulated model will be fabricated in a physical form. Um, During this process, the model can be 3D printed or fabricated during temporary materials or molds. The next step will be testing, where the fabricated prototype or sample is placed under extreme condition to ensure the quality and the reliability of the product is not affected by the damage. So after the testing is completed, the product remain its original form and function, which means it is ready to be launched or mass produced. So after the mass production, the product should be under continuous improvement, where the product faulty and customer claim will be taken into consideration, and it must be further enhanced or maybe improved for the next batch of production. Okay, next slide, please. So in every project, right, there is always constraint that will maneuver the end of the product result. So this is what we call it a triple constraint. So it is known in project management. So it refers to the boundary of time, scope, and cost, and it apply in every project. So the concept is the cornerstone, and therefore we must pay special attention to the schedule, of course, to the budget, and also the scope itself. So in any situation that we try to negotiate between these three constraints will affect our product quality, and also it will affect our product safety. So we need to be careful here, because sometimes, okay, the management, they want to have a product to be produced within a very short period of time. It can be possible, but it will cost more, and maybe the quality will be reduced by that. Okay. Okay, next slide, please.
Mr. Roslin,
Yeah.
perhaps you can have to watch the time a bit.
Okay, all right,
Yeah,
thank you so
thanks.
much. Okay, so okay, that is about the product development. So I'm going to touch a bit about sustainable manufacturing. So I will go truly briefly and fast here. So this is such an interesting topic that is discussed globally nowadays, right? So we know that this is the way of future. So next slide, please. So what is a sustainable manufacturing? It is the creation of manufactured product through economically sound process that minimize the negative environmental impact while conserving energy and natural resource. So the keywords here are conserving energy, natural resources, and the negative impact on the environment. Okay, next slide, please. So we know that industries are growing. So product manufacturing is shaping our world today, and to give us a better future to meet our ends need for our happier life, right? So nowadays, pretty much everyone own their mobile phone, everyone drive a car, and even own a house. So global manufacturing is meeting all these demands in the industry, especially in the big cities. But what will be the negative impact of it? So the biggest example is the increase of energy consumption, which we can see in the chart there over the few decades ago. So it is clearly that the energy consumption has increased in order to meet the manufacturing demand. So we know that oil and gas and also natural gases are still the main energy sources for the global manufacturing. So as the industries are emerging, electricity will be needed to power those manufacturing activity. Okay, next slide, please. Okay, what will be the consequences to the environment? There will be more carbon dioxide emission and also other harmful gases into the air. So we can see that in 2019, more than 30 billion tons of CO2 has been released, caused by solely human activity, right? Okay, next slide, please. So the greenhouse effect will drastically change the world temperature and heat up the surface of the earth, right? So with a hotter surface means there will be less water on the soil, crops will die, plantation will be less productive. In the end of the day, we are the one who will suffer for not getting enough food and clean water to drink. Next slide, please. Previous slide, please. I think you have been a little bit too far. Previous slide. Okay, this slide. Yep. So we should be using more green and renewable energy. So there are sources of energy in which we can invest in and explore, like the wind energy. In some country in the European, so they have already constant strong wind throughout the year. So in the offshore, for example, it can generate limitless energy. For some country in the Middle East and the equatorial line, they have a lot of sunshine throughout the year. So in Malaysia, particularly, even though we might have some cloudy days, but solar energy is already a good option for us to harvest the energy. So we need to use recyclable material at home, the office, manufacturing, and production using material like glass, aluminium, carton is pretty much needed. So we know, for example, right now, we need to reduce waste. So as you can see there, unnecessary packaging, which is over designed and over packaged. So this is something we need to think of, right? Okay, next, please. What else we can do? We can save energy, particularly at home or at work. Try to minimize the energy consumption by using energy efficient product. So minimize the usage of your air conditioning. So not only that, right? So we need to try to minimize the usage of our car. So we need to minimize the petrol, avoid unnecessary traveling. So apart from that, we can optimize our product design. So this will reduce the material use in the product by using simulation and also topology optimization in the product. It could improve the product drastically. And last but not least, using the technology that we have today, like Industrial 4.0, and using AR and VR, and also the Internet of Things that will reduce the cycle time of the operation. Okay, next. So it is you who will need to make the change that we need to make sure that our next generation will continue our effort. So the change is in our hand. So thank you so much. That's all from my side.
Thank you very much, Mr. Rustin, for enlightening us with the informative and interesting sharing. All right, let me introduce our next speaker, Dr. Kok Chi Kwang. Mr. Burhan, can you show the slide for for Dr. Kok's biography? Mr. Burhan? Yeah, can you show Dr. Kok's biography? Yeah, thank you very much. Dr. Kok Chi Kwang is currently a senior lecturer at the Faculty of Engineering and Technology, Multimedia University. He has been my colleague for some time. He's someone who is always full of energy and is passionate for teaching, research, and collaboration. He received his bachelor, master, and PhD degrees in mechanical engineering from Michigan State University, United States. And his research interests are in applied mechanics and engineering material characterization. He also works with local industry in his area of expertise. So again, if you have any questions to ask Dr. Kok, please post them in the chat box. So without further ado, let's welcome Dr. Kok. Over to you, Dr. Kok.
Thank you, Dr. Chen, for the great and kind introduction. I'm very, very humbled by the vast experience that Mr. Ruslin has displayed during the sharing of his engineering experience. It is indeed very impressive. We share some experience, the same experience working in Motorola. So today's topic would probably relate to Mr. Ruslin, and if it could conjure up some warm experience he had in his working life in Motorola, that would be really great. Please share the slide, Mr. Burhan, would you? So today I'm going to talk about product design for safety. I'm waiting for the slide to show. Burhan. while waiting for the slides to show, maybe I talk a little bit about what I'm going to present. I worked for Motorola for 5 years, and I had some experience developing a walkie-talkie for ATEX environment. Now, what is ATEX environment? Is basically an environment which is explosive. Mr. Burhan, have you found the slides? While working there, yeah, I got some experience in, yes. All right, thank you so much. So these are the typical environment users of walkie-talkie will be exposed to. You can see here we have the open mine, we have the oil rigs, we also have crude oil processing facility. These people are exposed to coal dust, methane, fire damp, as well as other dangerous substance. Next slide, please. Next slide. So when we talk about product design for safety, we need to know there are 4 hierarchy of controls. The first hierarchy, of course, is the elimination and substitution. Think about the pandemic for a second. What is the best way to counter the problem of getting infected? So, of course, the first and foremost, most effective method would be to eliminate the virus or substitute the virus by some variants that are less dangerous to human health. Second in rank with this hierarchy of control would be engineering control, which requires a change in the product design as well as the workplace. So we can think about, during the pandemic, what are the engineering controls we can do? Vaccination probably is a medical control, which typically very close to engineering control. Now we have the SOP, which falls into the third level, the administrative control, in which we implement some procedures to safeguard the workers and also the employers. The last, but is the least, unfortunately, would be the protective equipment, PPE, that we ask our frontliners to wear. So it's the same thing for engineering community. We would have to enforce PPE, but it would have to be the last choice of engineering controls for safety. Next slide, please. So now I show you a typical famous saw stop. It is a wood cutter that stops automatically when it is exposed to flash. So there's this sausage being brought to the moving blade. Next slide, please. As soon as the sausage touches the blade will stop by itself because it senses the conductance and capacitance differences. Next slide, please. So I will show you some other examples that we are probably familiar with. The first one on the left, you see smart safety. It's basically about safety equipment being connected to Internet of Things. For example, you could have like gas detector or radiation detector that are all connected to a dashboard for the display of monitoring of the workers' health and exposure. Now, the second picture here, you have portable exhaust. Exhaust had been made portable because it will provides the convenience of sites where workers will have to do their duties, for example, doing welding work or, doing foundry work, in which hazardous vapor would be exposing the workers to danger. The last picture there you see is redesign tools for ergonomics. You see that, there's a blade ergonomically designed so that when the users use the blade, the angle would minimize the efforts of cutting the cardboard. Other controls, we have mechanical guards, wet methods for dust, dilution, ventilation, and so on. Next slide, please. But today I'm going to focus on walkie-talkie. So these slides here will be tailored to walkie-talkie for ATEX environment. If you are developing products for ATEX environment, the general principles will follow. So designing a product for safety is as simple as 1, 2, 3. The first thing we need to ask ourselves, what are the customer's safety risks? So we need to get to know how the customers get into trouble. Next slide, please. So the best way for us to get to know that is to pay the customers a visit. So this is a site where the customers work. And when you get in touch with the customers, you may find some idiosyncratic behaviors the customers behave when using the products you design them for. For example, you may actually see customers using your walkie-talkies to hammer on things, which are not intended to be used as a hammer. And you may probably see them using the walkie-talkie and using them to crack some chestnuts when having a meal over a coffee. Next. So being exposed to the environment where the customers use the products you give you tremendous insight on how you want to design your products. Next slide, please. Because I'm talking about a text, the imminent things I need to say for the second step about the sources of danger would be what causes an explosion. Next. Now we know that an explosion can only happen when all three elements are present. First being the oxygen, second being the fuel, and third, the ignition source. The engineers would have very, very little control over the oxygen and the fuel because they are present everywhere during the workplace. But what we engineers have in control would be the ignition source. We don't want our equipment to cause any spark or hot surfaces that can actually endanger our users. Next slide. Next slide, please, Mr. Burhan. So I'm going to refer to these ATEX directories, which are a little bit old because I left the company a while ago. But the directories are still applicable. It's just refreshed to a newer standard for 2014. The products that I personally had involved myself in are displayed in the picture there. Next slide. Next slide. So to develop this project, engineers need to work very closely cross-disciplinarily around the clock to produce not only the products, but also the documentation. You can see an ATEX product actually requires tremendous documentations with tens of ring folders there. They are actually the documents we produce to be submitted to the certification body. We submit these documents to ATEX notified body in Germany. Next. So when a product, sorry about that. Let's take a look at the type of ignition we have, in a walkie-talkie product. The type of ignition source include hot surfaces, and of course, all these ignition source will translate into technical requirements. Okay. For example, hot surfaces will require engineers to think about the thermal requirements, the dissipative path of heat from the PA, for example. Mechanically generated sparks will require engineers to select materials carefully. We don't want to generate sparks because of mechanical rubbing. The electrical engineers will have to safeguard the circuit and make it into intrinsically safe circuit design. And also we need to consider static electricity, which is so common in a plastic enclosure. That means the plastic housings are so commonly found on walkie-talkie. When we rub against this plastic housing, there will be chances of electricity, static charge being accumulated on the surface. So what the mechanical engineers do are making serration that is changing the surface structure of the housing, or choose a material that is less conductive, less insulating, or more conductive plastic, for example. Of course, we also try to block the dust from going into the device and cause chemical reactions. Next slide, please. So here what you see are some ATEX or IECX markings. The ATEX markings are in the blue and the IECX markings are in the red or orange, depending on what color you see over there. So the ATEX marking are very similar to the IECX markings, and they basically tells the users what level of protection the equipment is giving to the users. So you will see very funny characters like, the Roman 1 or Roman 2, and then there's a numeric 2, and then GD. They all actually carry certain meaning. And I will explain these meanings, in the later slides. But it all gives you the protection level and also the temperature classification. Can you go to the next slide, Burhan? So the first Roman number over there basically designate the groups in which the equipment is designed for. Group 1 are for underground mining. Underground mining is the most dangerous, so it's group 1. Group 2 is exposure to gas, and group 3 is exposure to dust. Next slide. And there are different strategies to protect the devices against explosion. And because I only work on the walkie-talkie, so I would focus on intrinsically safe circuitry and also encapsulation. Next slide. So let me explain a little bit. As a mechanical engineer, I do not possess a lot of electrical knowledge, but I try my best to explain what intrinsically safe circuitry means. Say you are designing a circuit and you know that the circuit is very weak at a xenon diode. So you place two xenon diode instead of one as a redundant circuitry in case one of the xenon diodes fail. So that will be counted as one countable fault. So if you would like your equipment to be designed to have protection level IA, you need to protect the equipment fulfilling these three criteria. Okay, the equipment will survive in the worst case condition under non-countable fault. I will explain briefly. And it will also survive under one countable fault and two countable faults. So if you have two countable faults as the requirement, then your circuitry will need three Zener diode, for example. What are non-countable faults? Non-countable faults are shorting of ordinary components like resistors, transistors, traces of circuitry, wiring, and so on. The notified body has the right to short circuit or open circuit on any parts of your circuitry to form a non-countable faults. Next slide, please. So protection level IB is less stringent, as you can see. The equipment only needs to survive under non-countable faults and one countable fault. Next slide. And why are these countable faults so important? Because different protection level will enable the equipment to be used differently under different zoning. So now we talk about the zoning of hazardous environment, explosive environment. So we will have zone 0, zone 1, or zone 2, for example, for gas exposure. A zone 0 would means that the gas or the mist or the vapor would be present in definitely for a long period of time. So that is the most dangerous zone called zone 0. Zone 1 is also a zone where the substance is present, but it only presents during a normal period and not for a long period of time. Zone 2 would be the same thing, but the presence of the vapor would be for a very short period of time. Next slide, please. Now, the same classification also applies to dust, but the only difference is the zone will have a letter 2 in front of, followed by the letter where how severe the environment is. So 2-1 is a place where the dust will be there for, normal operation condition occasionally. And zone 2-2 would be a place where it only exists for like some period of time, very short period of time. Perhaps, pictures say 1,000 words. Let me just show you an example. Next slide. So this is an example, okay? On the left picture, you have a dust collector, which are so frequently, present in sawmill, for example, lumber mill, where there is like a lot of dust flying around. A lot of people might have misunderstood, thinking that dust is less dangerous than gas. It's not true. In fact, dust can be more dangerous than gas, because when an explosion happens, the dust will be stirred up. It will be a continuous sequence of explosion in a dusty environment. But for a gas environment, when the gas is used up, that's it. No more. There is no more ignition source. There's no more fuel. Sorry, there's no more fuel, and the explosion just die. So for a dusty environment, you can see the green area there, for example, before the inhale or the input of the dust into the dust chamber. That is a green area, but a little bit before that, you see a blue area. That means dust is present there under normal operation, occasionally. For example, when you switch on the dust collector, of course, dust will be present there for that period of time. So in the dust chamber, dust is always present. That is why it is a dangerous zone, zone 0. And then, after the air is filtered out, it goes out into the atmosphere. There's no more dust there, so it's a green zone. Another example on the picture on the right, you see there's a storage tank. Just
I think
assume
there
it
is
is.
some technical problem. All right, okay, Dr. Kok, please proceed. I thought there's a connectivity problem just now.
Okay,
Yes.
sorry, yeah. Okay, on the right picture, you see there's a crude oil storage tank. Just assume it's a crude oil storage tank. And workers, we have to go up to the tank. They need to open up. They need to perform some monitoring. So if you expose the vapor from the tank to the environment surrounding it, so there's a blue zone there. It has to happen under normal operation condition for a short period of time. But the vapor has always been present inside the tank. So the tank is zone 0. Okay, next slide. The last thing I want to talk about safety is temperature classification. So a T1 will have a protection against 450 degrees Celsius, the maximum temperature the device can get to. And then T6 would be 85 degrees Celsius. That means T6 is actually a lot more protective than T1. You can hardly design a product that meets 85 degrees Celsius because your ambient could be very hot. Under the hot sun, for example, is already reaching like 40 or 50 degrees Celsius. Then you also have to power up the system and the PA will heat up the system. So easily you can reach this 85 degrees Celsius. But why? Next slide. Next slide will answer you why you have different categories, because you are protecting against the flash points. That is the ignition point of different gases. So you can see in this chart over here, methane that is so frequently present in the oil and gas industry. It is actually the easiest to protect against, as you can see, because the temperature is quite high under this classification. But what if you have like carbon disulfide? Then you need a lot more stringent design. Next slide. So now I talk about the third part of the 1, 2, 3. The third part is, what do we do as engineers to eliminate the causes of explosion? That is the engineering control I'm going to talk about. Next slide. Because I'm a mechanical engineer, so I'm going to focus only on strategies I'm familiar with, okay, that being a mechanical engineer. But the chart over here shows you what are the typical applications and typical strategy in the column 2. Column 2 is typical strategy. Column 1 is the typical applications. Next slide. The first thing we do is encapsulation. This is so important, okay? So imagine this is the component. It's a very hot component when power up, say the power amplifier. You need to encapsulate it so it will be housed within a can shield, and then you have to have a minimum of 1 millimeter thick PU encapsulant on top of this component to make sure that the surface doesn't get hot. Because you imagine, this is what the notified body thinks. How does the gas go inside? The gas will always go inside. You have no way to stop it. So the internal surface of the system will have hot temperature. So the notified body wants to know if the gas get in touch with any surfaces, it shouldn't exceed certain temperature. That is why you need the encapsulant. Next slide. So I was a digital twin developer. I'm a simulation analyst. Okay, so the famous word or buzzword today is digital twin. So what I do is I simulate the fall of this product. I'm sure Mr. Ruslin is very familiar with this stuff because he designed battery pack. So you have a battery pack latched onto the radio, which we call as a tanapa. So we don't want the battery latch to actually disengage from the tanapa in the normal operation condition. How does that happen? It happens because when you are holding the walkie-talkie and it drops, the two can separate from one another. And when the two separates from one another, it is a very, very big issue. Why? Because there's a hole. The battery pad on the battery pack needs to contact the battery contact on the tanapa. There will be a seal, a compressive seal that protects the dust to protect the dust from going in. So if the two parts separate, if there's a gaping hole, the dust can go in all the way into the system. Okay, so you need to make sure there is no way they disengage. And we do simulation to make sure there is no way to disengage. We look at the stresses on the casing, the casting, the die casting. For example, we look at the meter stress. Next slide. Not the one before. You skip 2 slides. Okay, and this slide here, sometimes you look at the failure strain. We try to identify the weak spots and we need to do re-engineering. Next slide. So could you please play this movie so that people can see, what this movie is? This is a high-speed camera animation. Not animation, it's a real actual sequence of event that we hit on this radio. I'm not sure whether Mr. Roslin, no, this is a new radio, okay? So maybe he designed this also, I'm not sure. Please show the movie. There's a movie number 1. Yes, there's a pendulum simulating the drop. So the pendulum is hitting the radio instead of the radio. You see the two almost separating. Did you see there's like almost separation? So when you actually see this kind of thing happening, that means in the field, when this radio drop, there is a very high chance for them to separate. So you need to do redesigning to make sure this doesn't happen. Next slide, please. In the next slide, I'm going to show you a few other radios, okay, with very peculiar drops, peculiar angle in which the drop will actually results in disengagement. Could you play the purple radio thing? Okay, that is animation 2. Okay, please play animation 2. This is a radio. So you see, did you see the purple cover almost disengaged from the orange cover? Okay, the orange is the battery. Please play the third video. I'm going to do a cross section on this video, and you see what happened. The blue, the cyan color latch, and also the pink. Can you play again so that people can see? Take a look at the pink, the pink latch, the pink landing area and the blue landing area. Can you replay this video, Bahan? Replay this video. Yeah, replay this video. Yeah, you see? There is a huge gap between the pink and the cyan color part. This actually implies there's a disengagement possibility. Next slide.
I think Dr. Kok, you have to watch the time so.
Yeah. Okay, let me be quick. Okay, let me be quick. Next slide. Next slide. Next slide. I'm so sorry. Okay. Next slide, please. Next slide. I'm going to wrap up very soon. This shows the critical dissipative path for heat generated on the PA. So the heat will conduct out from the PCB, and there's a convection taking place, or they will go through the encapsulant, going to the can shield, then the thermal interface material or the thermal pad to the chassis. And this is to ensure that we do not have too much of a hot spot at a particular area. Next slide. So I will show something that would interest Mr. Roslin, the speaker. So speaker is a weak point. It is also a weak point not only in the intrusion of dust. You see this walkie-talkie being in the dust chamber. So you can see very beautiful pattern of this dust. I think it's because of it's a metallic dust that is get attracted to the magnet. So you see this flowering there. You don't want to see the dust inside and see speaker having the dust. So you choose different felt materials or some filter materials. Okay. The other weak point about speaker is a very sensitive component. That needs a separate test in the ATEX notified body. They actually develop very I'm afraid I can't show you here, but it's a cranky equipment. You put your speaker in, designed equivalent circuit that represents your radio, and if generated spark on the spot, your design will fail. It takes another 6 months for you to qualify the product again. 6 months, no kidding. So you don't want your speaker to fail. Okay, next slide. So I'm going to end my my presentation very quickly. I'm just showing you, sometimes we do continuous PTT, push to talk, or we do like repeater cycle. We want to see how things head up. Then we also do a digital twin. Next slide, please. So these are the results of a digital twin, where you pick the hot spots on different area. It's mostly more more useful for product design for dust, because you have your enclosure at the outside. If you have a hot surface that can ignite the dust, then that would be bad. So that will be the end for my talk. Thank you very much, Dr. Chen.
Thank you, Dr. Kok, for the sharing. I'm indeed humbled by the experience and the technical knowledge that these two speakers possess. So now we come to the Q&A session. Since we are going to look back at the content of this webinar, so perhaps we can discuss a bit about Mr. Roslyn's and Dr. Koch's presentation just now. So just some questions about Mr. Roslyn's presentation just now. All right. I think Mr. Roslyn, he actually mentioned that virtual validation is actually a part of the product design and development process. And in fact, I think this virtual is the hot term now as well. All right. So, but we understand that virtual can have its limitation in a lot of circumstances. So can we hear from Mr. Roslyn about what are the limitations that you have faced so far, in the virtual validation?
Okay, Dr. Chen. So, of course, there are some limitation, or I would say rather limitation rather to challenge. So the challenge that we have, or also the limitation that we have for the virtual validation or simulation, we call it, is that the output is really based on the input given into the simulation program, right? So the output is really depending on how you define the product. So the limiting characteristic of it, the boundary condition. For example, if I'm about to make a structural analysis of a speaker housing, which is made of polycarbonate or ABS. So it is important to understand the force which is reacting on the housing, the stiffness and the mounting point, the resonance frequency on the model structure. So all these boundaries condition really need to be set as the requirement of the product. So in order for the product to be safe and to withstand the testing and validation. So another limitation I would say is the resource limitation. So the virtual simulation or simulation really requires somebody with deep understanding and background of the specific program used for the physical boundaries of the product. So we really need a good hardware also, and computers and a good simulation engineers. So which is now we are lacking in our local industries.
Okay, thank you very much for the enlightening answer. All right, so we are going to have a question on the product design aspects, because we know that in the sustainable aspects of product design, all right, material selection, carbon footprint of the materials, as well as the disassembling conveniences for the joints, and all these play a part. So any examples that you have come across and may share with us in this aspect? Perhaps Mr. Roslyn can get back to us on this, as well as Dr. Koch on some sharing later on this product design aspect.
Yeah, sure, Dr. Chen. So in fact, in my last project with BMW, so they put a requirement to make the product which must be able to be reused or to be recycled at least another 1 or 2 times. So here are the material selection, the design of the product is pretty much very important. So the designers or developers, they need to think of designing a product which can be separated after the end of the life, right? So, for example, the speaker that we are developing for BMW, the internal housing bracket, for example, it must be able to be removed without any use of energy or maybe any use of heat. So, the polycarbonate material that we use with the code name of PCGF10, in which means the infusion of the glass fiber into the material, it must be coming from at least 30% of recycled material, and it must be able to be further recycled for other use after the end of life of the car itself. Yeah.
Dr. Koch, anything to add on this?
I just would like to say for the design of walkie-talkie safety overrules everything. So it would be very difficult for us, for example, to make sure that the design will be recyclable. In fact, when we do encapsulation on the PCB, that means the PCB is not useful anymore. Even if you want to have a reworking, you need to actually take out the encapsulant, and that is not very practical. So another thing like I can say is, for example, your housing cannot have any cracks because that will expose the dust into the circuitry. And for that to happen, you cannot use recycled plastics, because plastics, when it is recycled, it contains a certain amount of um, moisture that will actually degrade the plastic. Usually recycled plastic has to be grinded together with a new plastic, for it to be recycled to be used. So for us, I have to say the priority is on safety, the human part, and the sustainability part on the environment would be very little. Thank you.
Thank you for the sharing, Dr. Kok and Mr. Roslin. So I think in the slides just now also we see how certain parts has evolved through some virtual validation, perhaps like through FEM analysis on the stress and strain. Or also we see that how the parts have actually become more and more intricately designed. So it comes to the question to me that perhaps additive manufacturing has played a role in sustainable manufacturing, and in fact it's actually an important role here. So do you have any comment on this? Maybe Mr. Roslin first.
Yeah, sure. I think currently the additive manufacturing, like the 3D printing and rapid prototyping, has become a popular selection for most of the biggest industry right now, right? So this is due to its ability to be produced without huge effort and cost. So the 3D printing machine has become more reliable and cheaper right now. The material range has been increasing, and the the reliability of the printed product is also improving together with the technology used. So we can simply print a steel bracket from a metal 3D printer right now. So big machines like CNCs, stamping, and molds require typically more energy and time to produce the product, correct? So the impact is the energy consumption used by those machines to produce the part. So given the low quantity of production, for example, additive manufacturing will play a big role in sustainable manufacturing. So there is no need for CNC or maybe stamping tools or molds that will cost thousands of ringgit or maybe a few hundred thousands of ringgit. So we just order it from the reliable partner or supplier who own a 3D printer, or we own our 3D printer by ourselves.
Yeah, actually there are a lot of researchers involving this additive manufacturing as well. So perhaps Dr. Kok have anything to share on this?
Yes, in fact, it is a very exciting opportunity. The first thing we get to know, we need to know about 3D printing is the printed materials. Even if it is isotropic, when it's printed out as a part, it will not be isotropic. This is because the structure or the adhesion between the particles in the printed form. Maybe, let me just put it plainly. If you observe the printed parts under the microscope, you will see a lot of porosity. And this porosity may not be avoidable. And the porosity will structure itself differently when you have different raster angle, for example, or printing angle, or different infill, and so on. So all these parameters will affect the strength or the mechanical integrity of the parts you printed out. So the exciting part about this is people are trying to develop some kind of standards or some guidelines on how to print a part to match the mechanical integrity required for the parts. So it is a huge area. In fact, I've seen somebody presenting on automotive as well as aerospace parts. And as for the aerospace part especially, they need a special qualification or certification process. So if I want to replace a door hinge, for example, which is non-critical on the air jet, maybe I would print out the part, but give you the whole entire process on the parameters you use for the printing, the material you use for the printing, it needs to be certified. for aerospace industry to believe that the part will meet the mechanical integrity it requires. So exciting as in there are a lot of chances for you to do research, but there are also a lot of limitation, and those limitations are what is holding 3D printing back from being so vastly utilized. I give you another example. For example, in Motorola, it's very expensive to open tool, soft tool or hard tool to make a casing. Okay, so what are the alternatives you have? You probably will engage a machinist to machine the plastic for you to be used in prototyping phase. Or the other thing you could do is you could actually make it yourself using 3D printing. But the chances of the 3D printing surviving the radio frequency leakage would be small because there is a lot of porosity, in the printed form. So those are the things we need to be aware of lah. I mean, like, there's no straight path lah to heaven. Right, thank you.
Okay, all right. Thank you very much for all these insightful, sharing. And another question about what you shared just now, right? Dr. Kok shared about this peptides walkie-talkie. Also, we heard of this explosion-proof walkie-talkies, explosion-proof smartphones. Are they saying that these devices won't explode, under all classifications that you mentioned just now?
It depends on the classification. As you see, when I did my presentation, there's a label for each product. So you need to look at the label and understand what classification it is for. I could advertise my radio and say this is safe under zone 1, for example, okay, because I have the label that says zone 1. Please don't use this equipment in zone 0. It's not useful in zone 0, it will explode. So it's like there are different classification, like there's a higher ranking product and lower ranking product. Even though the claim is the same, this is a explosion proof. Even dust proof comes in two meaning, okay? Dust protection and dust proof is two different things. Like IP6X is a dust proof. That means the dust, visible dust will not go in. Visible dust will not go in. IP5X, for example, will mean is dust protected. That means some of the dust can still go in. But IP5X product is also an ATEX product. In fact, the lowest ranking ATEX product can reach is IP54. But IP54 is non-usable in zone 1 or zone 0. So it depends on the classification. The classification is very important. For example, we design a product for IB protection level. It cannot be used for zone 0. It can only be used for zone 1. Thank you.
Thank you, Mr. Rosalie and Dr. Kok, for the sharing. I think one last question due to the time limit. I think we noticed that a lot of industries, they are still hesitant towards adopting this sustainable manufacturing. We actually see a lot of challenges here, in manufacturing industry. So perhaps both of you can comment a bit about this before we conclude or we go to the closing remark of this webinar.
Okay, yeah, Chen, I can start first, I think. Yeah, you are right. So the biggest challenge right now is the cost of having sustainable manufacturing due to the low cost of energy right now that we are having, right? So the cost of electricity in Malaysia is pretty much low, plus the subsidy provided by the government. So this make the manufacturing cost very cheap in Malaysia. And by having a solar panel to replace TNB, the cost of capital is much higher. So it is not giving a quick return to the manufacturer, right? So this is why they are thinking, why they are hesitant towards adopting the sustainable manufacturing. But what can be done is, if the government give the exposures, make a policy to use the green energy as energy sources, incentive should be given, for example, and the bandwidth should be widened across the country, regardless of which industry. So, but as we know, all of this won't happen if we ourselves do not open our eyes, and we are still wasting energy everywhere. Yeah.
Kok, you have anything to add on?
Yes, it just reminds me of iPhone product that says, you know, they designed the end of life disassembly of the iPhone components. And when I look at the user's response, they would be saying, I won't pay the high price for the dismantling process. So it comes back to the users like us, like what Mr. Ruslin said. I agree totally, like 100% with Mr. Ruslin on his perspective on sustainability. When we talk about sustainability, there are these 3P, the planet, the people, and the profit. Unfortunately, the profit is the one most of us are not willing to sacrifice. And most of the users are not willing to pay the price for the other 2P. That is my personal opinion. Thank you very much.
Thank you very much for the wonderful sharing. I think we have got some very informative sharing today, which will be very useful to our undergraduate students or even some postgraduate students, and also for public knowledge. Yeah. So now we are towards the end of the webinar. As a closing remark, sustainable manufacturing and specific safety requirements are important to tackle environmental concerns mentioned just now, you know, such as pollution, consumption of natural resources. So to nurture a pool of workforce for sustainable manufacturing, we believe the industry needs a lot of competent mechanical product design and process engineers like Mr. Ruslin, like Dr. Kok. On the other hand, the institutes of higher education may have to work closely also with the industry to ensure that we work towards the sustainable aspects in the manufacturing industry. So in this aspect, we hope that we are going to have fruitful collaboration with Mr. Ruslin also in the near future, all right, in like what he actually proposed before in the electrification of cars, autonomous cars, and so on. And Faculty of Engineering and Technology, MMU, welcomes such collaboration, and please do come to us if there is such an opportunity. Before I end this webinar, I would like to thank wholeheartedly our speakers today, Mr. Ruslin and Dr. Kok, for spending your valuable time with us and for such a wonderful and insightful sharing. Thank you indeed. And also to our audience here for your time in joining us. And lastly, to the organizer of this webinar, our University Industrial Collaboration and Engagement Center, ICEC, the Center for Advanced Mechanical and Green Technology, CMGT, Faculty of Engineering and Technology, and the technical support team for making this webinar a success. Ladies and gentlemen, this is the end of the webinar. Please take care and stay safe. See you again. Thank you very much. Bye.